Hey guys, let's have a little talk about the difference between position, displacement, and distance, or path length. So we'll start with position. Let's say that I had a some kind of point, some kind of ball. Um, Position would be well, to define it, I'm going to need some kind of coordinate system. So let's go ahead and define. We'll just put some coordinates down. I'll put an axis. Call that the x. This is the origin 0. We'll go in increments of 1. So we have 1, 2, 3. This would be 4. So the position would just be the where the object is in relation to our coordinate system. And in this case, since I define this the positive x, this would have a position of approximately 4.5. Whatever we want to call this, we'll call it, I don't know, meters. So that would be position. It's the distance from the origin to the object that we're talking about. It is a vector, so this would be in the positive direction. So we could say positive 4.5 m. But now let's say this object moved. So it moved from 4.5. So we started here, and we're going to move it. We're going to move it over 5, 6, 7, 8. So we move it up to 8. So this is our second object. It's not really our second object. It's our second position. So now position 2, we'll call this position 1, would be 4.5, and position 2 would now be, what I think we said, 8. So it was still in the positive, so it would be 8 meters. Displacement would be the change in position. So the overall change in position. So I went from 4.5 to 8. So my displacement from 1 to 2 would be 3.5 meters. And displacement is a vector quantity, so we'll say positive. It was in the positive 3.5. Distance in this case would be the same. Distance would be how far did it move. So that would be, again, 3.5 meters would be our distance. But now let's move it again. So let's move it back. We'll go back 1, 2. So we end up here at 3. Position 3. So position 3 would be, that's 5, 6. So it would be in the positive 6.0 meters, because again, position just measures from here to where it is. Now the displacement is from the initial. So from here to here, what is the displacement? We don't care where it went in between. It could have gone 20 different places, but this is where it's ending. This is where it is right now, and this is where it started. So the displacement from 1 to 3 would be 1.5 in the positive direction, 1.5 meters. However, now the distance takes everything into consideration. So the distance would be from 4.5 to, what was this, 8? And then back to 6. So we would go from 4.5 to 8, which was my 3.5, and then add 2. So we would get a distance of 5.5 meters. So you can see that the distance and the displacement are not necessarily going to be the same. And displacement is a vector quantity, whereas distance is not. It's a scalar. So those are the basic differences between position, displacement, and distance. Let's try to walk through an example. Another example. Let's say we have a ball. The ball moves 10 meters down. Comes back 4 meters. Goes forward another 10 meters. and ends up coming back 11 meters. So then the question is, what is the ball's position at the final spot? So let's just say that's the final spot. What is this ball's position? Its displacement. And its distance. Now we're assuming that the movement was along one axis. I know that I drew it separately. This is just a motion diagram. So the ball was rolling down and back along the same axis. And we'll define this right here to be my 0. And we'll define this to be positive x. So I define that to be my origin. There's my positive x. So now I can start doing this. So the final position would be the 10 meters minus the 4, blah, blah, blah. I could do all the movements. But what we're going to do is so it went to plus 10 minus 4, since we're going against it, plus 10 minus 11. 10 and 10 is 20, minus 15 is 5. So the final position would be positive 5 meters. The displacement, so the displacement would be the same. The displacement would be positive 5 meters. Because we started at the origin. So those happen to be the same. In the example up here, remember or notice we didn't start at the origin. So we got a different final position and displacement. Now the distance. The distance is the magnitude of all of these. So instead of subtracting, instead of moving backwards, all I care about is how far did it move. Remember, distance is not a vector. So I just have to add these up. So I get 10 plus 10 is 20 plus the 15 is 35. So the total distance traveled would be 35 meters. So that's it. Just remember that position and displacement, these are vectors. Distance is not.